Unit 1, practice problem number 23 is one that I've gotten numerous questions on. So in this problem, you have an object that is dropped an unknown height above a window. So here's our object, and let's just call that height h for now. So we don't know how high it was dropped, but we do know that at some point later it falls past a window. And it is at the top of the window. We can call that t equals 0 seconds, and we'll set that as our 0 point in our reference frame. And then it takes 0.18 seconds to pass by the window, and the window is 1.5 meters tall. So I've set up a reference frame here where the downward direction is the positive direction. Okay, so we know we have, let's inventory our variables here. So our initial y position, we're going to call the top of the window 0 meters. Okay, our final y position is going to be equal to 1.5 meters. Okay, because the object was dropped above the window and it's accelerating, it does have some initial velocity v naught at the top of the window, but we don't know what that is. We also do not know what the velocity at the bottom of the window is. We do know it'll be greater than the velocity at the top, but we don't know either of those. We know gravity is 9.8 meters per second squared. And we also know that the time it takes to pass by the window is 0.18 seconds. So looking at what we know and what we're trying to find, it seems as though the equation that might be most helpful is y equals y naught plus v naught yt plus 1/2 gt squared, because we happen to know, we know y, we know y naught, we know the time, and we know g. The only thing we don't know is v naught y. Okay, and we are asked to find, in part A, we want to find that velocity at the top of the window. Okay, so this equation is going to be helpful, and now I have weird highlights all over, so let me get rid of those. But that's why I chose that equation. So let's go ahead and start. Well, first we actually want to rearrange this. So if we're going to solve for v naught y, let's go ahead and rearrange this before we plug in numbers. So we can subtract y naught from both sides and also subtract this whole term. Okay, so 1/2 gt squared, and that's going to equal v naught y times t, but if we divide both sides by t, we end up with an equation that will give us that velocity at the top of the window, at the point where it passes the top of the window. Okay, so we plug in our numbers, we get 0.15 is our y minus y naught, minus 1/2 times 9.8 times 0.18 squared, and we divide that all by 0.18 to get a velocity of 7.45 meters per second. And our velocity, even though it's downward, we have set that downward direction to be the positive y direction, so we can leave that as a positive number. And we would expect that to be a positive number. Okay, part 2 is then we need to figure out what is this value h. So what height above the window was that object dropped? Okay, so this, we just did A. Now let's do part B. Okay, let's do part B up here so that I don't have to move the screen. So for part B, if we're trying to find h, okay, we now actually know this velocity, right? At y0, we know the velocity is 7.45 meters per second. Okay, let's set up a separate kind of reference frame. Let's call this position now for part B. We can call this right here 0 meters. Okay, and we know that at 0 meters, because it was dropped, that the oh shoot, I said this was v naught. That's going to be our velocity after it's dropped, right? So our v naught, if it was dropped, will be 0 meters per second, and that corresponds with this 0 meters point. Okay, and we're trying to solve for h, which is a displacement. So if I know both my velocities, then my v squared equals v naught squared plus 2g y minus y naught is going to be a useful equation to use. And here, y minus y naught, that's just going to be our h, what we've called h, which is what we're trying to find. So that changes this equation. Our v naught is 0 because it was dropped. So that whole term is 0. So we get v squared equals 2g times h. So we take our v, 7.45 squared divided by 2 times 9.8 to give us our value of the height above the window from which that object was dropped. And we get a value of 2.83 meters.